Now in this video, we're going to look at a circuit fragment that I pulled from the Art of Electronics book. It's my favorite electronics book, and they used it differently though, and only mentioned it once, and I haven't, that I know of, and I haven't seen it mentioned anywhere else, so I'm going to give them credit for it. But the main thing is, right now we have 7 volts at the rails, the power supply voltage there. With the NPN bipolar junction transistor, I'm using a 2N3904, so we'll pull away from the power supply right now. And with this 2N3904, I'm measuring the voltage across the transistor. So the blue jumper there, it's the black probe for the oscilloscope I got here, and then they both come from the cable, and then we got the red one. So I just clip them to these jumpers. Makes it easy to plug it into the board to take a steady measurement. And there was some noise, as you can see. But in any case, the main takeaway is we just saw we have a 7 volt supply coming to the rails. Right now you see 5 volts. So each one of these squares going up is 1, 2, 3, 4, 5. Each square is 1 volt. So we got 5 volts. And I can set this to whatever I want, within limits of course. So I can't go all the way to 0 volts, as you can see there. And I can't go all the way to 7 volts, as you can see there. But the main thing is, we can set it where we want with the trimpot right there. And so here comes the nice part about this. There you can see we got the 5 volts. I'm going to go to the power supply. And so it's set to 7 plus a little bit, 0.1. That's because we lose a little bit of voltage through the wires and stuff. And it doesn't give us a nice full number. It goes slightly below the number. I'd rather go slightly above. Looks a little better. But in case, we got 7 volts being supplied to the circuit. Now we're going to go 8. So there is a tiny jump, but not a full volt at all. And 9, tiny jump. And 10, 11, 12. We'll even go to 14. So I just doubled the power supply voltage. And this may be maxing out one or more components power-wise, but in any case, I think we're still safe. But as you can see, we're still just a tad bit above 5 volts for what the transistor set. So I'm going to lower this now to 12. We made our point. But the main thing is, we can adjust the voltage as we want. Let's go to 3 volts. And so we'll go to 3 right now. And so when we lower voltage, it probably will dip a tiny bit, but for the most part, it's going to hold 3 volts, as you can see there. And now we can go below 6, because we got some room. But once you get really close to it, then you can see it starts dropping quite a bit faster right there. And in any case, let's actually build this circuit so we can look at it a little closer. So now I got the resistors out of the way, and we'll take a quick look at the transistor I'm using, the 2N3904. So it's an NPN type bipolar junction transistor. Any NPN bipolar junction transistor should work pretty well. It's kind of scratched, so it's a little hard to see the number, but in any case, it's 2N3904. So left pin's the emitter, middle pin's the base, and right pin is the collector. So we want the emitter down lower on the board. I usually work positive up, down towards negative, and not always though, so you got to be careful. But that's a good way to work. Positive down to negative, and also positive to the left to negative to the right, whenever possible. So in any case, we're going to put the emitter to that gray jumper going to the negative rail, as you see there. The middle pin is coming to one side of the resistive element, which is actually backwards from what you see here, but it doesn't matter. We set the voltage by turning the trimpot, and we went from there. And so all it's looking at is how much resistance is from the element to the wiper, whether the wiper, whichever side the wiper's on, isn't terribly important. But we can wire this as you see on the board. So that middle jumper there is the wiper. We'll move this down 1. So now the fixed side of the resistor is to the collector, as you can see there, and the wiper, the part that moves now, is to the base, the middle pin of the transistor. And so I'll just have to turn it the other way to get the same resistance. But in any case, we have that there. So we have, after we add another resistor, the 1 kilo ohm resistor. This is 1000 ohm. We're going to go from the base to the negative rail. So that will give us a voltage divider there. And so instead of using the trimpot by itself as a voltage divider, we are using, actually yeah, instead of going over to the board there, the pins are already close together, so I just stuck them like this, because connecting to this jumper is just like connecting to the negative rail right there. That's why they're so close. There we go. So it's a little harder to see though, but I think we'll just deal with that for now. There we go. I'll move it out of the way there. Now, this resistor, make sure we limit current, and because we're going to block a certain voltage, and it's good to limit current after that. And we could use a lower value resistor, but at the higher voltages, I went up to the 14 volts. It's good to have a somewhat higher value resistor. And literally, that's it. So, what this is going to do is try to hold about 0.7 volts approximately at that point. And if it gets higher than that, it will conduct better, which will pull the voltage down. And if it's lower than about 0.7, then it'll start cutting off the current there and allowing more to go there, so the voltage can build up more over there. So it's a balancing act. That's why it holds pretty steadily based on the voltage across there, not depending on the power supply voltage so much. As we saw before, it can impact it a little bit. So let's zoom back, and I'll move the light to a little bit better position, and without cutting the scene, we will grab the multimeter really quick and put the black jumper to ground, our 0 volt reference point. So the voltage we're looking at is in relationship to ground right there, and I have this other one that I will plug to where the collector and the resistor is. So we could use this like a zener diode, where we feed a voltage to another power supply, and since we have a resistor to the positive rail to kind of limit current, it is acting like a zener diode with the zener voltages. So let's go up to 5 right there. There you can see it's 5. I put the power supply back to 7 while we were away, and we go 8, 9, 10, 11, 12, even 13, 14. So I'm not going to do 14 too long. I didn't do the power calculations, but 12 we should definitely be okay for all the components on you see on the board there. So we did not change by a voltage, even though we doubled the voltage. So it's a somewhat reliable little voltage reference right there that we could, right now we're given the reference to the oscilloscope. We could give the reference to something else. As the voltage changes, it will hold that as long as there's enough voltage and all the components can handle the power. So in any case, I find this a really fascinating circuit fragment. Like I said, I've only seen it in the art of electronics, and I made a video on it in the past. And so that's it. I haven't seen it anywhere else yet, so I'm going to give them credit for it. So I have other videos popped up here. Please check those out, and make sure you subscribe and click the bell. Thanks for watching. I'll see you in the next video.